Okay, hello guys, I'll be doing some sums over the next few weeks. Please don't use this as a study material. Use this only as reference material. Any equation used in this video is purely coincidental.
Today is gonna be arithmetic progression. So what's an arithmetic progression? It is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. For example, this, all the odd numbers like 1, 3, 5, 7, 9, 11, these form an AP. These are an AP. Even numbers form an AP. 2, 4, 6, 8, 10. This chapter is mainly going to be dealing with finding these terms and finding the sum of these arithmetic progressions. Some important formulas you're going to be using throughout the chapter are formulas are 1. A nth or a tth, whichever you're comfortable with, is equal to a plus n minus 1 into d. The next one is sum of n terms is equal to n by 2 into 2a plus n minus 1 into d. Another one you're going to be using is Sn is equal to n by 2 into al plus a. Now what's this al? Al is your last term. Like maybe your series goes like 1, 3, 5, 7. 7 is your al. Okay? Now I'm gonna rub that off. You must know what a common difference is. Let's take the example of a simple series like 1, 3, 5, 7, 9, 11. Now by how much is this being incremented? Yeah, that's right, it's being incremented by 2. This is also being incremented by 2. This is also being incremented by 2. Same goes for everything. That means this fixed value is your value for d, which is called your common difference. And hence every AP is of the form A and then A plus D and then A plus 2D and then a plus 3d, and it goes on and it goes on, and it becomes a plus n minus 1 into d. So if you consider this as a2, this as a3, this as a4, then you can write d is equal to a2 minus a1 is equal to a3 minus a2 is equal to a4 minus a3, and so on. Okay, so now we know that there's no other easy method to learn maths than to do the sums. Okay, we're gonna do some sums. For example, we are gonna be doing the 6th question in the exercise 5.2. Okay, now we need to check whether this is a term of this AP. First we need to find the common difference. What's the common difference? Common difference is d is equal to a2 minus a1. Okay, now this is a1, this is a2. Okay, now what's the common difference? d is equal to 8 minus 11 is equal to minus 3. This is your common difference. Okay, now we are going to substitute in the nth formula. An is equal to a plus n minus 1 into d. Okay, now an is minus 150. Let's put minus 150 is equal to a. What's a? A is 11. a1 and a is equal. Okay, 11 plus n minus 1 into minus 3. N minus 1 into minus 3 is equal to minus 139. Now n minus 1 is equal to n minus 1 is equal to 46.34. So n will be equal to 47.34. Now n's value cannot take this form. N can only be a natural number. Okay, and now this has decimal values, hence it's not a natural number. So we can say minus 150 is not a term of this AP. This is question number 14 of exercise 5.2. How many multiples of 4 lie between 10 and 250? The multiples of 4 are 4, 8, 12, 16, etc. Okay, now what comes after 10? This comes after 10. Okay, fine. So start from this. So 12, 16, 20, 24. So go on. Okay, now what's this limit? We have 250. Wait, 240 is divisible by 8. 240 is a multiple of 4. So we're going to take this series. This is our series. This is our AP. This is our AP. Now we need to find the value of n. So how are we going to do that? We're going to put it in the equation an is equal to a plus n minus 1 into d. What's your an? Let's take this as this, 248. 248 is equal to a. What's a? A is 12. 12 plus n minus 1 into d. Now n minus 1 into d is equal to 236. What is your d? D is 4 because it's multiples of 4. See, it's getting incremented by 4. Incremented by 4. Incremented by 4. So your d will be 4. N minus 1 is equal to 236 divided by 4, which is equal to 59. There you go. Which is equal to 59. Okay, so n minus 1 is equal to 59. N is equal to 60. Okay, this is how much multiples of 4 lie between 10 and 250. Next we're going to be dealing with questions using the formula this one. Sn is equal to n by 2 into 2a plus n minus 1 into d, and Sn is equal to n by 2 into al plus a. We're going to be using these equations for the next few questions. Okay, so this question is taken from exercise 5.3, third question and fourth subpart. So it's given A3 is equal to 15 and S10 is equal to 125. They want us to find the value of D and they want us to find the value of A10. Okay, so we're going to be using this. A3 is equal to A plus n. What's n? 3 is n, so 3 minus 1 into d. So 15 is equal to A plus 2d. Now S10 is equal to 125. So S10 is equal to, what's n? N is 10. 10 by 2 into 2a plus 10 minus 1 into d. Now that is 125 is equal to 5 because they gave the value of that over here. Okay, so 5 into 2a plus 9d. Now you can cancel it over here, so it becomes 25 is equal to 2a plus 9d. Now let this be equation 1, let this be equation 2. Now multiply equation 1 into 2 and write it over here. That is 30 is equal to 2a plus 4d, and 25 is equal to 2a plus 9d. This is equation 1 multiplied by 2, and this is just equation 2. Now when you subtract equation 1 multiplied by 2 minus this, you will get, let me subtract, these will get cancelled, and this will be 5 is equal to minus 5d. That is d is equal to minus 1. Now we have the equation a3 is equal to a plus 2d. Now a3 has been given as 15 is equal to a plus, we just found out d is minus 1, that is minus 2. Okay, so a will be equal to 17. Now we are going to substitute that in this. We need to find a10. So a10 is equal to a plus 10 minus 1 into d, which is equal to 17 plus 9 into minus 1, which is equal to 17 minus 9, which is equal to 8. So you have the value of d as negative 1 and a10 as, well, 8. Okay, this is question number 14 in exercise 5.3. Find the odd numbers between 0 and 50. Now what's the odd number after 0? It's 1. And what's the odd number before 50? That's 49. Okay, now there is 3, 5, okay, till 49. So your an will be this, and your a will be this. Okay, now we know the formula. an is equal to a plus n minus 1 into d. That is 49 is equal to 1 plus n minus 1 into d. Now d is equal to 2, because see, everything is being varied by 2, and then I don't know whatever but 2. Okay, so it's 48 is equal to n minus 1 into 2. Now that is 24 is equal to n minus 1. N is equal to 25. Woohoo! Now we're going to put it into the formula s n is equal to n by 2 into a l plus a. That is equal to 25 divided by 2 into 49 plus 1, which is equal to 25 divided by 2 into 50. You can cancel that, you can make it 25. So your final answer should be 625. Voila. Okay, so this is example 15. Now an is equal to 3 plus 2n. So what will be a1? A1 will be equal to 3 plus 2 into 1, which is equal to 5. Now what will be a2? A2 will be equal to 3 plus 2 into 2, which is equal to 7. What will be a3? A3 will be equal to 3 plus 2 into 3, which is equal to 9. Now we can see that there is a pattern over here. It's being incremented by 2. Now we need to find sum of first 24 terms. That is, you have s24 is equal to 24 n divided by 2 into 2 into a plus n minus 1 into d. Now that is equal to 12. 12 into 10 plus 20, 46 is equal to 12 into 56, which is equal to 672. There you go.